Now let's talk about the meter bridge. To find the resistance, this meter bridge is used. Meter bridge is working on the Wheatstone bridge concept. You are able to see the galvanometer here, the resistance box. This is your meter bridge with the jockey. And we are able to connect your unknown resistance here and the known resistance here. This is your meter bridge. Let's move on further on meter bridge. So meter bridge is one form of Wheatstone bridge. It consists of thick strips of copper of negligible resistance connected. There are two gaps G1 and G2 between these strips. A uniform manganese wire is connected AC of length 1 meter whose temperature coefficient is low. Is stretched along a meter scale and its end are soldered to two copper strips. An unknown resistance P is connected in the gap G1 and a standard resistance of Q is connected to the gap G2. A metal jockey J is connected to the bridge B through a galvanometer G and a high resistance HR, and it can make contact at any point in the wire AC. Across the two ends of the wire, a Leclanchic cell and a key are connected. Adjust the position of a metal jockey on meter wire so that the galvanometer shows zero deflection. Let the point be J. The portions AJ and JC of the wire now replace the resistance of R and S of the Wheatstone bridge. You got P, Q, R and S. So by formulation we got P by Q is equal to R by S is equal to R resistance into AJ and resistance into JC. R is the resistance per unit length of the wire. It's cancelled. You become P by Q is equal to AJ by JC, which is equivalent to L1 divided by L2. So P is equal to Q is equal to L1 divided by L2. Though the connection between the resistance are made up of thick copper strips of negligible resistance, and the wire AC is also soldered to such strips, a small error will occur here in the value of L2 divided by L1 due to the end resistance. This error can be eliminated if another set of readings are taken with the P and Q is interchanged and the average value of P is found, provided by the balance point J is near to the midpoint of the wire AC. Now let's talk about the determination of specific resistance. So this is how the experiment is done. The specific resistance of the material of a wire is determined by knowing the resistance, radius R and length L of the wire using the expression rho is equal to P pi R square into L by divided by L. This is how you will be calculating the resistance. If R1 and R2 are the resistance of a given coil of wire At the temperature T1 and T2, then the temperature coefficient of the resistance of the material of the coil can be determined using the formula alpha is equal to difference in the resistance by product of the individual resistance kind of R1 into T2 minus R2 into T1. This founds the determination of temperature coefficient of the resistance.